Hey everybody, Dr. A here, and in this video we're going to be exploring another example of shear flow. So let's go ahead and get started. Given to us, we're being told that a beam subject to a shear force V is made of two boards nailed together with two rows of nails at 6 inches longitudinal spacing. And then we're being asked to determine the maximum shear force V, same V that we set up here, that a section can support if each nail can support a 210-pound shear force, okay? So let's look at a cross section here. This first figure is a cross section. So what we have is two rectangular boards that are being nailed together by two rows of nails, okay? And so the dimensions here, we got a height of 2 inches of the top board and then a height of 3 inches of the bottom board. And the width here, I hadn't drawn this yet, but the width here is 6 inches, okay? And then on the right figure, we have a side view, all right? And of course, this dimension here is the 2 inches. The bottom vertical dimension is the 3 inches. And then on the side view, that's where we see the 6-inch spacing. And this is typical between all of the nails. So 6 inches here, 6 inches here as well, all right? And so, so again, what are we doing here? Well, here we're actually trying to find the shear force V, all right? So let's go ahead and write the solution. We're going to say little q is V times capital Q over I about the neutral axis, okay? And so what we need to find is really is V, okay, is V. Knowing that we have the spacing and we have the strength of each nail, okay? And so let's go ahead and get what we would call Q allow, all right? Q allow is going to be the nail strength divided by the nail spacing, all right? And so Q allow is going to be computed as 210 pounds times 2 rows divided by the 6-inch spacing. So that's this red 6 inches here. Now why 2? Again, we've got 2 rows of these, all right? And so when you punch that through, what do you get for Q allow? Well, you'll get 210 times 2 over 6. And so you're going to get 70 pounds per inch. So now we can check off Q in that equation, okay, little q, all right? What about I about the neutral axis? Well, this whole thing nailed together is one big rectangle, all right? So we're going to be able to say I about the neutral axis is BH cubed over 12. So that's 6 inches times 5 inches cubed over 12. Now, this 6 inches here is this horizontal 6-inch dimension of the wood boards themselves, right? So we're going to say 6 times 5 cubed over 12, and so that's going to be 62.5 inches to the fourth. So now we can go ahead and check off the moment of inertia, all right? What about capital Q, all right? What about capital Q? Well, capital Q, same definition that we've seen before. That's going to be A prime times Y bar prime, all right? Now, we've got two pieces of material that are both rectangles, and we have an interface here that these nails must penetrate through, all right? So we can call either one of these portions A prime. You can call the top rectangle A prime, or the bottom rectangle can also be A prime, all right? So I'm just going to go ahead and call the top rectangle A prime. I'm going to say A prime is 6 inches by 2 inches, so that's 12 square inches. All right, so here's our A prime. All right, now what about Y prime bar? Well, Y prime bar is going to be the distance from the centroid of A prime to the overall centroid of the whole section. Well, the whole thing is a rectangle, right? So we can say that regular Y bar is 5 inches over 2, which is 2.5 inches. And so Y bar prime is going to be what? Well, it's going to be the distance from the centroid of A prime to the overall Y bar, all right? So that's going to be 4 inches minus 2.5 inches, which is 1.5 inch, okay? And again, how do I know that? Well, you know, the overall neutral axis is right here at 2.5 inches, okay? And then up here is A prime. So Y prime bar is right here, all right? And so finally, I can combine some things together and I can get Q is equal to 12 times 1.5, and so I get 18 inches cubed, all right? And now I can check off Q. So now I can do a little bit of rearranging and I can get V equals little q times I, about the neutral axis, divided by capital Q, all right? And so little q is Q allow, that's 70 pounds per inch. And then I, about the neutral axis, is 62.5 inches to the fourth. And then divide by 18 inches cubed. And what do we get? Well, we're going to get 70 times 62.5 divided by 18. And so we get 243 pounds as that shear force, okay? So that concludes this example. If you found this helpful, please hit like and subscribe and be on the lookout for other material like this. Thanks for watching.